gave you a lot of techniques for solve for evaluating definite integrals and indefinite integrals. It's just that we lied to you. We're suggesting you're so wonderfully adept at evaluating integrals, but in reality, most integrals outside the math classroom door cannot be evaluated analytically. So when it comes to solving differential equations, even like this one right here, sometimes I really get stuck. And I'm going to have to rely on some kind of approximation technique. And we will be doing just that, because I really am stuck. I think we've exhausted our possibilities for evaluating an integral. Yes?
So the point of this exercise was to bang our heads against the wall?
Yeah, for you guys to apply as much as you can, and also for me to make a little introduction, is that we have to get around this.
Are we using summation techniques?
Kinda. When you say summation, I think you're referring to, what was your favorite phrase in Math 31?
Power series.
Power series representation for solutions of DEs, so we can generate what they look like. So I'm afraid on the left-hand side, I have to wait for, let me count, 14 weeks? We'll get there. But you know what? I'm not tricking on the right-hand side. I think on the right-hand side you can do something. Who's on the right-hand side?
Trig sub.
Okay. Secant or sine?
Tangent.
Yeah, I think tangent. And if I came in and I allowed, I don't know, you guys, how did that substitution go? You tell me. Do you like Z's? W? Anybody? I'm trying to review integration. Chris? I was hoping you say none of those.
Yeah.
When it comes to trig sub, it's a very backwards type substitution. I'm going to take the variable I already have and set that equal to something in terms of another variable. In this particular case, wouldn't that be the tangent of maybe a theta?
Yep.
Make up a whole new variable? I'm trying to shake you up. These trig subs are very backwards in that we take the variable we already have and set it equal to something. Paying the consequence of my actions, I suppose that means dx is, actually, I don't know what, I'm slow today. However, committing to substitution in the integrand position, let's do it and I write out what we have. Well, you start out nice. Downstairs, what do we have?
Parentheses.
We'll simplify it downstairs. Secant cubed up there. However, upstairs I think I've got tangent squared theta. I think to the right I've got
Secant square root of theta d theta.
And I think when I clean this mess up, it's simply going to give me the integral of the tangent square root of theta over the secant of theta with respect to theta. What we do is probably your best bet, only because I've got the secants downstairs, not upstairs. I probably would have done the same thing. And so if you and I commit to both the ratio and reciprocal identities from trigonometry and then reciprocate and multiply, I think that's going to give me nasty business on the left-hand side. Equals, I don't know on the right-hand side, is the integral of the sine of theta over 2 cosines, is that correct? Sorry, now I'm just getting too tired.
No.
No.
Oh, am I wrong?
Well, you only had
I'm so sorry, I am wrong. I really did make that mistake. Is that better?
Yeah.
What would you do next?
U sub.
Oh, does it use some work? I wasn't thinking of that. That's difficult for me to see.
Oh
so.
well. Oh, never mind. If it were another way, well, we could.
I would. Because I think upstairs, if you apply your very first Pythagorean identity, you're simply going to get this.
That's right.
Which is simply going to give you this. Which is simply going to give you this. Actually, I'm talking too much. You talk.
Natural log of absolute value secant of theta plus tangent of theta. Minus sine of theta plus c.
Or shall we say? Actually, I don't know what we'll say. I don't know the answer.
Got you by your triangle.
Got another name for this?
Another name for that?
What was that?
Hyperbolic sign.
Yeah, because I think the absolute value is superfluous. And that being the case, I think it's just the inverse hyperbolic sine of x. Right. Did I walk in the right classroom? Okay. Oh, I feel so free. I can do examples and push you guys in your integration techniques. So how about something like number 7? Where tell me what to write.
Separate it.
And if I separate them, do I get this? Okay, I claim defeat again. Jeepers. Hold on a second. Ah, better again. So that could be this. Do you guys agree today, at this point, I'm just being silly and truly just jogging your memory on integration techniques?
Yeah.
No, seriously. I think this all is. My very
Yeah.
first step, separation of variables technique, is just one step. The rest of it's just integration. No tricks this time. You can do this. What would you do over here?
Trig sub.
Would you really?
Oh, actually, no, you don't even have to. Well, you could do a trig sub if you wanted to, but
It's a nice pen that's drying out.
that's just the inverse sign.
In this one.
Inverse sign, right?
It's no. Inverse.
Oh, inverse secant.
If I had the absolute value of y on the outside. I just tried, it doesn't work.
Multiply top and bottom
By what?
by the right.
I just did, it makes it worse. Really? Alright, I was expecting you guys just to give me the answer. And if you can't give me an answer, that's fine. Give me the appropriate technique.
Why don't you use a trig sub again?
A trig sub would be the appropriate technique. I was just hoping to give
Okay.
you the answer. But if you were to use a trig substitution, what would y be?
It would be sine.
I can't hear you.
Why?
I can't hear you. Say it again. Well, if you're going to use a trig sub, y would be
Y equals sine of theta, right?
secant?
Secant. Oh yeah, secant of theta.
Okay, one person agrees. And if you're going to apply a technique, if y is equal to secant of theta, then isn't my denominator just simply, sorry, I'm going slow now. Is that just a single tangent of theta?
So if it were 1 minus y squared, then it would be
That's
sine of theta,
different,
right?
that's
All right.
different. As a matter of fact, Brad, if it were 1 minus y squared downstairs here too, I would have just stated the answer. The answer will be the inverse sine
Okay.
of y. Upstairs is my one. It's just that if y is equal to secant of theta, I think dy becomes
Secant of theta,
secant
tangent of theta.
Tangent of theta.
Then the tangent of theta is cross out.
Good, so I think on the left-hand side, I'm simply
Then
left with the
you
integral
just
of
have secant of theta.
Do you guys mind if I stop? We already have that. It ends up being the natural log of the absolute value of the secant of theta plus
Tangent of theta.
tangent of theta, and then you back substitute. I was just hoping you guys would say, oh, I could glance at that. I know what the integral of values too. It's just inverse high
Hyperbolic
hyperbolic
something.
Jeepers. And on the right-hand side, do you guys mind if I don't finish the left-hand side?
Yeah.
Because even if you didn't see it, you just go ahead with the natural log of the absolute value, secant theta plus tangent of theta, and back substitute. But what about the right-hand side?
Integration by parts.
I can't hear you. How about partial
Or
fraction?
partial fraction
decomposition?
decomposition.
And I think since I've got a rational expression that's proper, I think partial fraction decomposition is the way to go. Shoot, that means I need scratch paper. Aside. No calculus. I'm talking basic algebra. Let's you and I take this fraction, 1 over this product, and set it equal to, talking too much again, over
X plus 1.
plus
B over X plus C.
all over.
X squared plus 1.
And then we're moving fractions. I guess it tells you 1's equal to a times this binomial plus the product of these two binomials. Of course, you guys, I'm tired. I don't want to go through all the work of equating these coefficients, generating 3 equations and 3 unknowns. But if I did equate 3 equations and 3 unknowns, I could certainly solve the system by using reviewing for chapter 2 of this book. Use the technique of true, but it's from your past as well. Gauss?
Oh, Gauss-Jordan
Short
elimination.
on a Riemann matrix? If you guys don't remember, don't worry about it. You can just simply rewrite it as a single matrix equation and use.
Kramer's rule?
I keep walking the right room. Inverse matrices?
Inverse matrices.
Or use Kramer's rule in terms of using determinants.
Isn't Kramer's rule always kind of the best to go with?
I think everybody would agree that the worst technique ever to apply is Kramer's rule.
Really?
As a general rule, think about it, watch. You got a determinant to evaluate. That's a 2 by 2
Yeah.
piece of cake. Product on the main diagonal minus product on the non-main diagonal. But if you got a 3 by 3 determinant to evaluate it using a cofactor expansion, we rewrite it as a sum of 3 2 by 2s. But now what about a 4 by 4? Cofactor expansion brings out the sum of 4 terms of 3 by 3s, but each of which has 3 2 by 2s. I think there's a lot of computation there. And so I think as the size of your system increases, the complexity of the algorithm for a computer scientist increases horribly. And so that's why with big systems, Kramer's rule by far is the worst technique, unless you can find a trick around it. And there is a trick. And I can't think of the name.
Are you going to teach it to us?
No, I don't actually remember it.
No.
Who wrote Alice in Wonderland?
Lewis Carroll.
I can never remember the name, I'm sorry. I've never read the book. But Lewis Carroll was a mathematician. He came with a really slick technique for evaluating these big determinants, kind of a shortcut. I only know this because years ago I was teaching Math 33, and I had some honor students who just came across it, and they presented it to me, they showed it to me, but I just can't remember the details.
Look it up. Go on.
You can easily look it up, yes. You guys, I don't want to go there, it's too much work. So instead, I will take this linear factor here, identify 0, and simply allow x to be the 0, that linear factor, which is -1. And if I do that, I see that a is equal to 1/2. Shoot, that was fast, but the rest are not. Now I gotta slow down. To find values for b and c, how about equating coefficients of x squared? And I think on the left-hand side, here's a coefficient of x squared. That's equal to the coefficient of x squared on the right-hand side, which I think is a plus b. But that necessarily implies that b is equal to -1/2. I'll circle it because I'll forget otherwise. And lastly, equating. How about just my constant terms? And if I equate my constants, well, here it is on the left-hand side. But here they are added together on the right-hand side. I guess it necessarily implies that c is equal to a +1/2. And if you guys are okay with my arithmetic, that means on the right-hand side, I get to rewrite this integral as nothing more than the integral of my a. Help me, you guys. A is 1/2 over an x plus 1. Plus my b times x, which is -1/2 times x. Plus my c, which we found to be, thank you, all over x squared plus 1. Do you guys think we're proficient enough? Just write down an answer.
The natural log of x plus 1, the absolute value of x plus 1 minus something.
This is why your pens are always out of ink.
Do you remember who associates a letter grade to your name at the end of the Guys, come on. 1/4, I heard that. 1/2. Oh, shoot, you're almost there. Inverse tangent of your x plus c. Or shall we say more concisely, this is nothing more than, I don't know, is that a 1/4? The natural log of x plus 1 twice over x squared plus 1. Plus my 1/2. Inverse tangent of x. Plus. Anybody? Help me. Yes, no? Yes.
How did you get the x plus 1 squared?
I thought I'd pull out a common factor of 1/4, but in terms of quarters, I guess it's 2 of them. And I took the 2 and threw it upstairs to square things so I didn't have to write the answer in marks. Yes, sir.
You're subtracting 1/4 natural log of x squared plus 1, so why did it end up on the bottom in your final answer?
It did. There's my x squared plus 1 at the bottom.
I'm just can't read things.
It might think that's sloppy, I'm sorry. Anybody else want to attack me on this, please? Okay.
Wait. Bring up the flow.
Oh, no tricks though, no tricks.
You put your 1/2 into the natural log of x plus 1, right? So shouldn't that be the square root of x plus 1?
See, I disagree. I think I had a 1/2 here.
Yeah.
But if I cross it out, can't I rewrite that as a positive 2 over 4?
I see what you're doing.
But then I took the numerator, the 2, and I threw it up in the exponential position. So I'm shaking you up on your math 31 and your math B. Oh, let me make one up out of thin air, see if we can do this fast. Where am I? Number 8.
The 7-2, the y back.
It's 7 to the y.
7 to the 1, yes. You guys able to just sit there and give me the answer on the left-hand side? 1 over. 1 over.
Natural log 7.
Natural log 7 times being equal to the integral of 1 over. Partial fractions. Unfortunately, I can't.
I would complete the square in the bottom. And then do a trig sub.
I can't hear you.
No trig sub?
No, I'm too
Why
tired.
not?
Besides, the class is almost over. Can't we just state the answer?
Is it one of those hyperbolics? Because I don't know this.
No, not really. Dodge. You guys, am I doing okay? No, like that.
I have no idea what you just did.
Jesus. Well, watch my clumsy
Alright.
hands. Don't you agree that if I made a use of? It's 1 over u squared plus a squared. And if you were to integrate 1 over u squared plus a squared with respect to u, wouldn't you just get a 1 over a inverse tangent of x over a plus c?
Yes.
It's just that my a is root 3 over 2. I divide on the outside by root 3 over 2. I invert it and multiply. Yes.
You mean the inverse tangent of u over a plus?
Thank you. My apologies. I'll keep my variables straight. I didn't do u over not x over a. So I just simply reciprocated the a, which is just simply the reciprocal of root 3 over 2. That reciprocal is 2 over root 3. And I think my a downstairs right here is going to be a root 3 over 2. It's just when I undo my u sub, this is x plus 1/2. But take the x plus 1/2 over root 3 over 2 and just multiply top and bottom by 2. Don't you get that?
Where'd you get A? That's,
Where to get A? Well,
Yeah.
This summer session in Math 31,
yeah.
I proved to you that if you're going to integrate this piece right here, you get this. And Brad, you said it
Okay.
correctly a moment ago. You said, oh, just make a trig sub. You're right. I'm just saying, I made a trig sub once in this case. I just was hoping that we remember what the answer was. only because it pops up often.
Okay.
Then I kinda hope you know to integrate this piece to get that. And if I'm being silly, if I'm saying too much, don't listen to me. Your trig sub will be just fine. You probably
Okay.
just come in and set let my x plus 1/2 be equal to the tangent of, excuse me, I misspoke. I meant √3/2 times the tangent of theta, and you'd run with it. That would be
Okay.
your trig sub in this kind of case. I just did my hand.
Okay.
Come on, you guys give me some feedback today. I'm done. I don't say anymore.
Let's get a log summary.
Okay, that's what I was worried about. And I think I'm just using this opportunity to shake you guys up saying, well, now you can just get up and running with the integration. So do you think we'd be ready for our first take on this weekend?
Sure.
It's not even Thursday yet.
What's that? Yeah, actually, I'm saying in my head, I'll create one today and I'll give it to you tomorrow for the weekend.
So there's no in-class quiz
Oh,
tomorrow?
no, there is an in-class quiz.
Okay.
I'm just saying, are you ready for a first take on this well? And the in-class quiz tomorrow, we'll go up through the homework, excuse me, tomorrow. Yeah, I got my days straight.
Yeah,
Tomorrow's
Thursday,
Thursday.
tomorrow.
It just won't cover the homework that I'm signing now.
Okay.
So it'll be 1-1 and 1-2, right?
Yeah, and that's it.
Yeah.
However, in 1-3 and 1-4, I get some practice. I haven't done very much today. I hope you know I'm being facetious. I'm sorry for all the evens, you guys. They were just too nice to pass up.
Oh. The solutions manual actually does all the evens.
Yeah.
Oh, also it's an
It's
instructive
awesome.
solution manual, huh?
Yeah. There, oh, I
There's
got
for
I got
free
one
which
on
is
online.
really nice.
Yeah.
You know, I'm sure a student gave me a copy of that. I just haven't opened it up.
Yeah, I got it from Catherine.
Then I've got the same
Yeah.
thing. I've got the same thing. You guys, if these are too easy, just do all of them. Let me know
It's
how they
all
go.
easy.
Of course it is. So don't forget, in-class quiz tomorrow.
I'll get to that.